Alright, so we're live now, so we don't see anything bad, right? Right, first one is what? Potassium permanganate, acidifier, yeah? Yeah. Okay, so there's some potassium permanganate. Alright. It's purple, right? So you're going to get your nice coloured pencils.
Oh, I'm going to colour it purple.
And shade it in purple. Okay, all I've done now is add some sulfuric acid to it. That dilutes the colour, of course, without doing anything else to it, just dilutes the colour. And of course, if you think about the half equation, it's providing what? It's providing what? It's providing what part of the half equation for permanganate do you need? What does the permanganate half equation need? You've written that half equation at least half a dozen times in the past week. What else is in the reactants? Find it on your book. Permanganate. It provides the hydrogen ions in order for the reduction to the No. Okay. This is iron 2 ammonium sulfate, which is simply a source of Fe2+. It's got a very pale green colour in, as you can see, okay? So when I take some of this and pour it into here, it's a very, very pale green. Okay? There's a magic change and it turns from purple to colourless. Okay, that's acidified permanganate reacting with iron 2+, okay? The ammonium ions and the sulfate ions and the potassium ions are all the ammonium ions, the sulfate ions and the potassium ions are all ions. The time for stupidity is past, Bailey. They're not involved in the process, they are spectator ions. What's the second one? Acidified potassium dichromate. Okay, well here's potassium dichromate, which is an orange colour. Into that we'll put some sulfuric acid. I think it might already be acidified, but you can never have too much acid, I say. We're adding to that also iron 2 ammonium sulfate, which again is very pale green. Okay, what do you expect to happen here? You've done the equation this week. Change colour to green because of the not chromate.
Iron 2 dichromate.
Chromium 3, yeah. Okay, and it's green/blue, teal. Notice the difference in what you can see here and what you can see on the screen. Alright? I think that is the colour of this thing here. I think that there's a fault with part of the colouring, but you can see the colour from where you are, right? It's a greeny blue, cyany, tealy colour. Yeah? Teal. Teal's a colour. Do you know what it stands for? T-E-A-L? Was the original name of Air New Zealand? What was the original name of Air New Zealand?
Actually, teal.
Actually.
What was the original name? What's the brand that colour? Yeah, teal.
Tasman and East Asia Airlines. That's what it stands for. The word teal, yeah. Alright, what's the third one? And hydrogen peroxide? Okay. Surprisingly, potassium permanganate hasn't changed colour since the first one. It's still purple. Okay, so there it is, okay. And into that I'm putting some hydrogen peroxide. This is hydrogen peroxide, it's a colourless liquid. This is 20 volume hydrogen peroxide. That means it produces 20 volumes of oxygen for each volume of H2O2. So it's quite strong.
White.
And there's also effervescence in there. You can't really see it where you are, but there's lots of bubbles in there as well. Okay? It's moving too fast, actually.
I see
Okay?
bubbles.
There's lots of bubbles. What are those bubbles formed from this?
Hydrogen.
Make sure your brain is engaged in here before I open your mouth. Not hydrogen. Oxygen. Okay? At least one person's been looking at their list of common oxidants and reductants. That's good. Now, providing you can get the marks for the whole class, we'll be okay. Okay, the next one is? Potassium permanganate and? Oxalic acid. What do you remember about oxalic acid? It's poisonous. Okay, this one is interesting. It should go quite slowly.
Is that colour solution?
That's an oxalic acid there. Yeah. Colour solution, yep.
No, it's not.
No, it just takes time, this one.
Oh.
6 minutes.
Top it up.
Yeah, why not?
Well, what's it done?
The colour's been diluted, of course, yeah, but we're interested in the actual reaction rather than that.
Need to increase the
You reckon? Make it go faster? If in doubt, make it go faster?
Let's make it very fast. It's not fast enough.
Yeah,
Oh, okay. No. I don't get it that easy.
It happened.
There's my cutting plan. I'm just going to heat up some oxalic acid there, okay? Because this, I think, will change. I'm going to leave this one aside, and I think it will change. Okay? But we'll heat some oxalic acid up so I can repeat it with hot oxalic acid. What's the next one?
Sodium thiosulfate. Peroxide.
Sodium thiosulfate.
It's not, that's on the 6.
Sodium thiosulfate.
hydrogen.
Acidified hydrogen peroxide and potassium iodide. Number 6, is it? 5. Okay, so hydrogen peroxide, colourless liquid. Colourless liquid? No, colourless solution. Add to it sulfuric acid to provide some hydrogen ions, yeah? Okay, plus potassium iodide. Here is potassium iodide. Colourless solution. Okay, very quickly that colour is produced. That colour is the same colour as stuff here. What's the label say? Iodine. So iodide is turned into iodine. We can confirm that by putting in some starch solution. And what colour should it go?
Purple.
Blue-black, eh? Okay, it's going pretty much blue-black, yeah. This is not good starch solution, I was using it last period, okay? So the product, one of the products is iodine, so iodide has been oxidised to iodine, okay? So that means the hydrogen peroxide must have been was expecting an answer there. If iodide has been oxidized to iodine, then hydrogen peroxide must have been reduced. Okay? Alright, what's the next one?
Sodium thiosulfate and iodine solution.
Okay. Yeah, well, there's a slight technical hitch there.
Yeah.
Hey, what do you want to know,
Just like my signature.
Sodium thiosulfate and iodine, yeah? Okay, here's my sodium thiosulfate with the correct formula on it. Okay, it's a colourless solution. Alright. I'll put some of that in there. Okay. And to that I'm going to add some iodine, which of course is the brown solution. Okay, we'll use the dropper here so you can see the colour of it.
Will I find this on YouTube?
What, this particular video?
Yeah.
Unlikely. Here's the brown iodine solution being added in. Why is it not spinning? Who took the spinner out?
You.
It's magic. The brown colour is disappearing. That means the iodine has reacted, okay? It's actually the reverse of what it did before. Before iodide was oxidized to iodine, this time iodine is being reduced to iodide. So therefore the sodium thiosulfate, in fact the thiosulfate ion must be
Oxidized.
oxidized.
Yeah.
Good. I'm pleased we've got Bailey in the class so we can get some answers. Even if they are, oh look, this one's disappearing. Alright? It's disappearing. You ready? I think the oxalic acid might be hot now, we might repeat it, eh? So what number are we going back to? 4. Permanganates.
Oxalic acid.
Oxalic, not auxilic.
I'm
It's not an auxiliary. I don't believe that's a racist. I believe that's just correct pronunciation. All right. Okay, so warmed oxalic acid now. No, it's still a slow reaction. Okay, but it might be quicker than. I should. And if this doesn't work, that's what I'll do. Because heating them both up will increase the collision, increase their kinetic energy, and increase the rate of collisions between both particles, won't it? Okay?
We need it from some more magnets. So
Like a what?
from some more magnets. So
Throw in some more magnets. You think the magnets have some effect on it?
yeah, a lot.
Really?
How did your flag
Make you go past that.
Yeah, we need to speak.
Huh?
How come your flag is married?
Oh, so I can use the keyboard with the macrons on top.
Macro.
Macrons, line over the top? You think that's changing?
No.
Oh, I do.
Yeah, I see it. I see
Slight,
it.
slight change.
Right. If Bailey sees a change, there must be a change because Bailey is all seeing. Yeah, now look.
Yeah, boy.
It's actually changing through a different oxidation state. Actually, that one there is something like manganese 5+, that red colour. That's not important for what we're doing. But I think we will do it again at hot with both of them heated up. Oh, look.
What? Saying it in last video.
Don't be too big.
Is that like yellow?
It's just a little library.
The vortex in the middle, can you see the vortex in the middle? If I actually, I could stick something down there which won't even get wet. Yeah. Well, my finger won't fit. If I do it, I use a big beaker, I can. Right, it's going right through to colourless, which is Mn2+. In fact, you can see, right from permanganate, you can see a range of colours on that one. It's quite good.
Can you increase the speed, sir?
I can, but I'm not going to. And we'll do that again in a moment. I'll heat up both ingredients, all right?
Then it got colourless.
And we're colourless. Next one. What are we up to? 7. Acidified potassium iodide. Potassium iodide. Once again, colourless solution. Okay, just make sure there's no tricks, nothing up my sleeve or anything. Okay, and sulfuric acid, so that's our mixture, acidified potassium iodide. What am I putting into it? Potassium iodate. This is potassium iodate. It's also a colourless solution. And straight away, immediately, instantaneously, there's quite a reaction, and we've got a dark brown solution and a kind of blacky solid formed in here. Okay? It's actually iodine. Iodide and iodate were turned into iodine. Okay? It's a dark brown solution with a black precipitate in it. Okay? And it smells like iodine.
There's still more copper.
Okay, what's the next one?
Copper sulfate.
Copper sulfate, potassium iodide?
Yes.
Okay, this is a Kleck's reaction.